Now for our next task number 3, manual tunnel with ISISv6. We need to configure a ISISv6 on R1 and R3 to advertise their loopback 3 across the tunnel, and then we need to observe the result. So on R1, just to quickly enable the ISIS, do interface tunnel 1. Command is IPv6 router ISIS. Question mark, we have to give it a tag, so LM. And then we go under the router ISIS LM. First is we need to provide a net ID, and we can just come up with pretty much anything that complies to the format. So we're going to start with 49, and then Cisco support 6 octets. System ID, so 000, 000, and then just end with 1, and then ends with 00. Okay, and to advertise loopback 3, we'll do passive loopback 3. Okay, and this is just the minimum config that we need to enable ISIS. If you want to go into more detail on this, we have a separate video on ISISv6 that you might want to check out. So that's for R1. If we do show CLNS interface, we should be, let's see, detail, so interface TU1. You can see that currently the tunnel is up. It's enabled for both level 1 and 2. Okay, now doing the same thing on the R3 with interface TU1, IPv6 router ISIS LM, with the routing process ISIS LM, with the net ID of 49, quad 0, and then 0003, 00. And to advertise loopback 3, we do passive loopback 3. Okay, and let's restart our Wireshark. Let's filter also using the display filter with IP source equal to 162.16.0.1. And based on our Wireshark packet capture, we did not see anything or any ISIS packet coming from R1. And if you do a show CLNS neighbor command on R1, you see we do not see any neighbor adjacency on R1 or R3, so show CLNS neighbor, no adjacency. And obviously ISIS does not work across the manual tunnel, and that's pretty much our observation there. So to move on to our next task, which is the GRE tunnel with ISIS version 6, our task number 4. Now we're going to have to change the tunnel mode from manual to GRE, and then we need to verify the ISIS adjacency comes up across the tunnel and verify connectivity between R1 and R3 loopback 3. And then we're going to look into the Wireshark packet capture and make a comment of why ISIS failed to operate back in task number 3. Okay, to enable or change the mode from manual to GRE, on R1, getting under the tunnel interface 1 with the tunnel mode, instead of IPv6 IP, it's going to have to be GRE, question mark, and then over IP. Since our transport protocol is IPv4, if you wanted to do an IPv6 over IPv6, then the transport protocol would have been IPv6. But here we have our transport network to be IPv4. So enter. And then on R3, same thing with tunnel mode, GRE IP. Okay, so you can see as soon as we do that, our neighbor came back up as far as EIGRP that we configured back in task number 2. And now if we do show CLNS neighbor, you can see now that we have neighbor adjacency with R1 across tunnel 1. Okay, and it's forming across both level 1 and 2, since both R1 and R3 are level 1-2 router, and the protocol is ISIS. Okay, so if we do show IPv6 route ISIS, here we are learning R1 loopback 3 address as well, which is 2001.102. Okay, and the next hop being the link local address. So let's do a show IPv6 interface TU1. You can see how the link local address has changed. So do show run interface TU1. Although we're still sourcing from loopback 0, you can see how the link local address has changed to use the R1 interface MAC address instead. That makes up of the interface ID. Okay, as before, it was the actual source loopback 0 or embedded IP within the link local address. Okay, so it doesn't really make a difference, and if we do show IPv6 EIGRP neighbor, we should still have the adjacency on that as well. Okay, now let's take a look at our Wireshark capture. Since we still have that running in the background, you can see before we only had EIGRP, or we only saw EIGRP packet, but as soon as we change the tunnel mode, let me actually stop that so it does not scroll anymore. Here you see some ISIS packet. We got both ESIS or ISIS hello packet. And you can see how the ISIS packet writes on top of the GRE header that's encapsulated inside of IPv4. So you can see that ISIS doesn't really rely on the IPv6 header, and that's why it doesn't really work when you have the tunnel type as manual. And the ISIS actually requires the GRE header for that to work. As you can see right here, GRE tunnel has a protocol type specifically for ISIS. Okay, since we have the ISIS packet captured, we might as well just take a look at the inside real quick as far as what we have. Hold down timer default is 30. Circuit type, this is where it advertises itself as supporting both level 1 and 2. Obviously system ID with quad 0, quad 0001. And then area address, which is 49, the digit in front of the system ID that we specify as part of the net ID. And then if you look through this, you see two sets of packet exchange as far as one for level 1 and one for level 2. Okay, I'm just not going to go into details of each of these packets, but basically it's exchange was taking place to form the adjacency. And obviously we saw that we have the adjacency when we did the show command, and we verify with the ping, and we know that's working. Actually, I don't think we have really tried to do a ping, so let's do that. We just verified we have adjacency and routes. So from R3, if we ping, let me enable that back with continue without saving. Ping to 2001, 102, 1 sourcing from loopback 3. You can see those are pingable. And if we hop onto, let's clear the display filter. And here we have the packet that's coming from 2001-3023, which is R3 loopback 3, going towards 2001-021, which is R1 loopback 3. The packet headers, we have IPv4 from R3 loopback 0 to R1 loopback 0. Right after that, we have the GRE header. And since this is just a regular IPv6 packet, right after the GRE header, we have the IPv6 header. And then we have for our payload is CMPv6 ping request. So you can see how we have the additional header inserted right between the IPv4 and IPv6. And this is the price that we have to pay if we want to support any other layer 3 protocols other than IPv6. In our case here, that protocol is CLNS as part of ISIS. As opposed to if you were to use the manual tunnel, you will have the IPv6 stack right on top of the v4 without additional header, but obviously you will not be able to support any other layer 3 protocol across the tunnel. Okay, so last bit of check, we want to ping from R1 to R3, 2001-302-3, sourcing from loopback 3. Okay, and that pretty much verify our bidirectional connectivity between R1 and R3 across the GRE tunnel. Now just to sum it up, if all you need to transport across the tunnel is IPv6 traffic, then you can just use the manual tunnel. But if there's a need for you to transport anything other than IPv6 as a layer 3 protocol and have that flexibility, then you will need to configure it or use the GRE tunnel, but at the cost of additional GRE encapsulation or GRE header. So that wraps up our video on IPv6 manual and GRE tunnel. You can visit our website to view an extensive list of our lab videos and sign up to get access to additional lab contents. Thank you for watching LabMinutes.com, and I'll see you guys in the next video.